Hi, everyone. It's Judy Warner. Welcome back to this week's Ecosystem Podcast. Today's guest is probably one of the most interesting people I've talked to on the podcast about how he's onboarded a systems-based approach to engineering that comes from both complex engineering systems and his concurrent role as an officer in the Air Force in the active reserves. So concurrently, he was onboarding engineering and being an operator of complex electronic systems, and he's a pilot, both in peacetime and wartime. He's onboarded such unique approach to engineering. I think you're going to enjoy this conversation and onboard so much. It was such a rich conversation, though. I'm going to break it into three parts so you really can take advantage of everything. And please just listen and enjoy and know that everything we're talking about is going to be in the show notes. And thank you so much to our sponsors, Keysight Technologies, Translate Technology, and Signal Integrity Journal. In this conversation with Ben, we talk about publications he's done and articles he's published in Signal Integrity Journal and through DesignCon. Again, all the links are in the show notes. And if you haven't done so, please be sure right now to go over to thedoubleecosystem.com. I'm getting ready to put out our first newsletter, and I will be setting up an online community where you can talk to Ben Dannan, Eric Bogatin, Steve Sandler, and all the guests that I feature here on the Ecosystem podcast. That way, you can continue the conversations that I begin here every week on the Ecosystem podcast. Again, thedoubleecosystem.com, and there's some free technical resources to say thank you for becoming part of our community. Now let's jump right into this exciting conversation with Ben Dannan of Northrop Grumman. Hi, Ben. Thanks so much for joining us today on the Ecosystem Podcast. It's so good to see you, my friend, and I can't wait to have this super geeky, awesome conversation with you.
Thanks, Judy, for having me.
Well, I thought you would be so interesting to our guests because you're really unique, system-based way that you look at systems, and particularly in your role at Northrop Grumman. So for our audience, why don't you start out giving a brief overview, because it's really unique, about your education, your engineering, and particularly your role that you have right now at Northrop.
Sure. So at Northrop Grumman, I'm currently a technical fellow in the BWI area, working in the ASIC development team. Most of what I do day to day is at the system level from a modeling perspective, right? So I spend a lot of time doing measurements and modeling. People come to folks like me in the group and a couple others when they want to know if the system is going to work with their design. So I'm the guy they come to model it. I started actually a long time ago at, some folks might say not that long ago, but at Purdue University. It's where I got my undergrad and double E, right? So I'm a geek, right? You can't spell EE without, or geek without EE. So,
Right.
and then I did my master's in electrical engineering at Penn State. They have a signal integrity center there. So when I lived there and worked at a few companies, I was able to finish that. And then along the way, I've been in the reserves in the Air Force almost my entire career. So currently I'm a major in the reserves, and I started off flying. So most people, I'd say, weapons system officer or WISO, and people are like, well, what's that? I just say, well, I'm Goose, right? So if you know Top Gun, I'm Goose. So I'm the guy that's basically pushing the button and the majority of the strike platforms, or a guy in the back that's driving all the EWO or electronic warfare equipment.
Yeah, so no grass grown under your feet. Like, I don't know, how do you manage that dual role of being in active reserves and a career?
It's a balance. I think it starts by having a good partner, right? So my wife is, she's been my rock for a lot of it. And even when I was coming and going, she didn't know if I was at home sometimes. I mean, it's a balance, right? There was a point where I was flying, right? So the way the tempo would work was typically I'd work full time, depending on where I was at the time, whether I was working at Bosch or BAE Systems or even a previous role in a robotics company. Typically, I would work a 40-hour week, but one day a week I would leave to go fly. I would go up the street to fly. And it was a long day. So you figure you get up at 8 a.m., you start work, you're in the office by 8, and I leave around 2 or 3 to go and pre-flight and mission plan for a flight, or training sortie, we call them, that would take off at, like, I don't know, 6 p.m. and we wouldn't land till 10
Mm.
p.m. And we'd be done debriefing typically around 11 or midnight, and I'm in bed by 1 and back up at 8 a.m. the next day. So it's a balance, and did that with grad school. So yeah, it's definitely a balance. You have to fight, and there are some compromises you make along the way to keep that balance, but it all works out in the end. So I had some great experiences, and yeah, so it's something I definitely don't regret.
Well, in a long conversation we had recently, I was so fascinated to learn about that. And just, if you can, you have so many amazing stories, and I can see the direct link between the really rich experience you've had in the reserves and how that impacts your whole approach to engineering. Just because our audience, we're all geeks here. So what kind of planes did you fly? And I know you saw some wartime also.
Yeah,
So tell us a little bit about your flying hours, what kind of
sure,
plane you flew,
sure.
and, those tours.
Sure. So where the Air Force sends folks like me, weapons system officers, we go to Pensacola Naval Air Station. That's where flight school is for us. And we start off on the T6 platform, which is a great platform. I love that plane. I mean, you do low levels at 500 feet, 240 knots. You have to wear a full G suit. We do a full aerobatics phase where I'm on the stick and we're doing all the aerobatics, pulling 6 Gs up to 7 Gs, which is the max for the airplane. Then we move on to the it's a Beechcraft. It's a T1. It's like a Learjet where I'm sitting right seat and I'm basically acting more in a nav or weapon system officer capacity. There's some equipment in the back that I'll rotate in to operate for training and mission qualification. And then the final airframe that I spent time on, well, there's one other I left off, which was the Diamond DA-20. There was an Air Force screening program that was before the T6. But then I go to the EC-130J as the final platform. EC-130J Commando Solo. There are 7 of them in the Pennsylvania Air National Guard, and they're the only 7 of its kind. And we do a MISO mission, or PSYOP, psychological warfare. MISO stands for Military Information Support Operations. And it was an awesome mission. It's under the SOCOM umbrella, which is under AFSOC, right? So AFSOC goes up to SOCOM, right? So Air Force Special Operations Command. So by definition, I was considered an Air Commando. And most of what I did, because SOCOM owned that mission, right? That special ops mission was all tasked to support special operators. So everything they did was supporting guys downrange, doing various things, right? Commando Solo, the name speaks for itself. So if you think
Is that
about
your nickname,
Solo,
really? Commander
no,
Solo?
Commando Solo, the name of the
Oh,
airplane,
Commando
right?
Solo.
Yeah,
Okay,
so it
I'm
speaks
with
for
you.
itself. In other words, we did very clandestine sort of missions
Okay.
where if you think about what PSYOPs is, we're the folks that, depending on who our tasking authority is, people may want to know we're there or may not want to know we're there. And
I
that's how you
see.
have a psychological effect, right? So it's a very interesting tactic and it requires some sort of secretive nature at times to be effective. But it was a really cool mission. I got to see tons of places. And along the way, I deployed to Iraq and Afghanistan in different settings. In total, I have over 47 combat missions in those 2 theaters, and I over almost 1,000 hours of total flight time, and over 250 hours of that was combat time. So it
That's
was it
so
was fun, right?
amazing.
Been around, seen some things.
I really, really want to pull the Maverick thread right now, but I'm going to save it to the end
Sure, sure.
because we have things to talk about there. But that's such an impressive, and again, I don't know how you've managed all of this, but it's such a fascinating thing. And I wanted to talk about it because I think it will tell our audience so much about your perspective and maybe onboard some of those principles
Sure.
and experiences so they can learn from you. Um, so you mentioned earlier that you're a technical fellow at Northrop Grumman, and you said it in passing as so casually. And, we share a friend and Steve Sandler. And when he told me that, I'm like, wait, don't only guys who are much older with gray hairs get technical fellows. So why don't you touch on that briefly? Like, how did that happen?
Oh, well, I mean, I just tell people I'm just being me, right? So I took I've always had the mindset that just play hard and have fun, right? And that's kind of what I was taught in the military. You know, you work hard, you play hard. And so I didn't ask for it. I came to Northrop in 2020, which was weird because I started in the middle of a pandemic. My 2020 was very different from most because I lived in 4 states, right? Because I was on orders at the time, transitioning from one company to Northrop. And I worked at Northrop for about a year, and they said, we want to put you in for a technical fellow. And I said, okay, sure. So a year and a half, here I am, technical fellow, and now I'm pushing 2 years at Northrop. Having fun. It's a great company. Um, I think some of the things I do on the outside, right, those intangibles really help and they add value to what I do day to day. I'm always working with folks on the outside on new ideas outside of work, where I'm working with folks for maybe another DesignCon paper or maybe an app note for Pico tests or writing or working with companies to try new things and figure out where things break. Um, you know, you can't be a good engineer unless you've broke things along the way and you've learned from other people's mistakes or you made your own, right? So sometimes you just gotta hit your head against the wall, and some people it takes a little more head banging than others, but at the end of the day, that's what makes a lot of good engineers is just really grit and hard work. So there's really no secret sauce than that.
Well, I think you and I first encountered each other through Altium, I believe.
Yeah.
But then quickly after, we also share a friend in Bert Simonovich who has presented many DesignCon papers and won. So when I met you, Bert Simonovich had helped you write your first paper.
Yeah.
And so I sat in your first paper. And it was a really good talk.
Yeah.
And we were being your elderly cheerleaders, I think. Sure. And so that's how I really first came to know you. And you were telling me about, at that time, your experience in the military. But in my mind, I sort of thought this, to me, you're a kid. This kid is going to go places because he's doing that after hours stuff. And he's learning, and he's obviously put himself forward, to mentors and people like Bert Simonovich and Steve Sandler and some of these things. So I could see that early that you and now all these years forward, how many papers have you done for DesignCon now?
3 Ben? Total, but in the last 2 years, I think I have over 17 publications, papers, presentations, and app notes, something like that. So
that's amazing. So for our audience, I'm putting links to everything Ben has published in the show notes. So please go dig in. You'll love it. And we're going to talk about one paper in particular.
Sure.
Why don't we... Oh, and the other thing that I just learned about you is that with the podcast I did a couple of weeks ago with Steve Sandler, we were talking about his designation as a Keysight ADS Certified Expert. And he said, oh, Ben Dannan has that too. And I'm like, wait, aren't there only like less than 100 of those? And again, I'm like, what's up with this kid? So tell us how that came about and what kind of inspired you to go down that avenue.
When I was working on some things for grad school, which ended up being one of my papers that I published at DesignCon, actually the one that Bert and Lee Ritchey also helped mentor me on that paper.
Okay.
That work kind of was the culmination or the starting point of what kind of led to some things that I did later, where I showed Keysight and got sponsored by someone at Keysight to become a certified expert. So
nice.
Yeah, I mean, just hard work, right? Putting in time, learning the tool. There's really no secret. It's a great tool. That's why I love Keysight ADS. I mean, Steve says this all the time, right? There's really still to this day no simulation tool that you can do end-to-end simulation like you can with ADS.
Yeah, he really talked about that in his podcast, that end-to-end, which again is a mindset you've adopted. And really, it's the point of this whole podcast.
Yeah.
Right? And is to help engineers on board that systems based thinking and integrate the different parts, because you can be doing, let's talk about that right now. Because before we began recording, you were talking about the disconnect between, I'm going to let you tee it up, between power systems and power integrity, I think is. So why don't you
Sure.
unpack that bit of a conversation we were
Yeah, I mean,
having?
today I think you wanted me to tell one more story, and I'll lead that into this, right?
Okay.
So today
All
it's
right.
harder than ever to be a systems guy, right? So
Yeah.
I say to everybody who asks me, I've been a systems guy. I just seem to be going smaller in the systems I'm working on. Started on ground
Right.
combat vehicles, then worked on moving cameras and mechatronics. Went
Thank
up for
you
a
for
minute to
reminding me.
robotics, where I had fully autonomous robotics platforms. Now to smaller systems like ASICs, packaging, and board level specifically. I did all those things before, but they were on bigger systems. These are smaller. And
Okay,
so,
wait. You're right. I did want you to tell that story. I don't want to interrupt you,
oh, sure.
but make sure, let's talk about, as you continue to unpack this thought here, how you were telling me about how you went on the ground and the disconnect you saw between engineering and the operator. So pick up that thread.
So why I joined the military, right? I think it was in my blood always, right? My dad was in the Corps. My grandpa served. So there was always a desire to serve. And out of high school, my dad stopped me and said, no, get your degree, do whatever you want. So I did. I worked for a few years. And then I said, maybe it's time, maybe it's not. Well, I went down range for a program. I was in Iraq for when I was working at BAE Systems, and I was his lead site engineer. And before I'd gotten to that, I started off in manufacturing, then worked over to R&D. My manager at the time, he said, look, if you want to design systems, you need to cut your teeth first in manufacturing and understand how we build these, where the
Yeah.
pitfalls are, because then you know how to design for industrialization, right? And he was right. It was great. Well, you get requirements, right? And R&D, and you put systems in, you design, and you launch platforms, just like in every, market,
Mm-hmm.
whether it's commercial or defense. It doesn't really matter, just the requirements are
Right.
different. So here I
Mm-hmm.
am downrange, right? And I'm in a combat zone. I was in Balad, Iraq at the time, and it was really cool. Here I am, this young kid, right? And I'm the only engineer on site, and there's all these mechanics and other technicians coming up to me for every time there's a problem. So they come to me for sign off. And the way it would work is we were there to do basically vehicle upgrades in theater so that way we can get the vehicle back to the operators as soon as possible. And so this was a SOCOM platform. It's what that means is Special Operations Command. And that the users on that vehicle are Rangers, Deltas, those sort of guys, the kind of tip of the spear soft guys. And so
Right.
literally
That's
we're
exciting.
high-fiving each other as we're doing a vehicle swap, right? And you get the
Right.
vehicle, you're unloading RPGs, grenades, ammo, other used things in there, like used shells, just so we can do all the upgrades. This is a big upgrade. And I remember this one vehicle coming back, and the requirement had this component that we put in there. And I say to the guy, I'm like, hey, man, why'd you take that out? He's like, oh, dude, it sucks. I was like, what do you mean? He's like, it gets in the way of the mission. And I said, well, that's not what the requirement said. He's like, yeah, man, it totally impedes the mission. And
Mm.
it was almost like a light bulb moment for me where I realized to really be a better engineer, I need to understand more of the human factors. I need to understand from an operator perspective. And so that's where I knew I wanted to go into the military at that point, and the time was right. Right? It's because I'd worked a few years, and so I had this buddy. He was an Apache pilot in the Guard, right, in the Army Guard, and he says to me, he says, Ben, you have plenty of character already. You don't need any more of it. So you don't need to roll around in the dirt anymore to build character. Don't join the Army. Join the Air Force. They treat their people better. So he was right. I joined the Air Force, the Air National Guard. And I never looked back. Yeah, I mean, go figure. We go places. We get air conditioning. So for those other prior service guys out there, you can make fun of me later. But yeah, so I joined the Air Guard, and I kind of stumbled into the flying side. But the way it worked out, I couldn't have planned it, and I have no regrets. And I learned how to be an operator. I was an operator, right? So I flew airplanes. I operated a lot of mission equipment. I worked on systems. I tactically employed those systems, and I found where they suck. And I can tell you for a fact where there was a system that I was trained on by Northrop Grumman before I worked at Northrop Grumman. It was a countermeasure defensive system. And we would go downrange, and most of the time we would turn it off because it would fail. So we
Oh,
would have to tactically change things. But this is normal, right? This is how a lot of operators work. So if you really want to understand how operators are going to use it, you need to think like an operator. And so that's been something that I've carried with me ever since, right? All the training and deployments and other things. So fast forward now, right, to the other point you were talking about.
mm-hmm.
So what I spend most of my time on, it's still systems, but now from a power integrity and signal integrity perspective, right? I found
There
a
we go.
passion there, right? I had a good mentor
Yes.
with Lee Ritchey where we did some really fun work together at the last company I worked at, where I hired him as a consultant, and we ended up building a good kinship along the way. And there was this EMC problem that we had. And to this day, when we're around drinking like wine in a circle of friends or
Yes.
something,
Lee Ritchie and his red wine.
yeah,
I've had some of those times and
yeah,
I love it because I learned
yeah,
so much from him.
yeah, exactly. So he always will tell people when he's with me, he's like, Ben, you got to tell them about the EMC problem you had. And he says, this was the hardest or worst EMC problem I've ever seen in my life. And it took a lot of work, but we fixed it. And it's a great story. I don't want to unpack that too much here. But
Yeah.
fast forward now to what I've been growing towards and working on at Northrop, where I see the gap today, and it's everywhere, is if you look at things from a system perspective, there's still delineations, right? Look at it as a
Yes.
simple example, right? Keysight, we talk about power integrity and power electronics.
Mm-hmm.
So if you're trying to do power integrity and power electronics, there's a delineation there. But really, as a systems guy, there's not. Because if I'm trying to model a system end to end, I need to understand everything from the ASIC through the package, through the board to the VRM. And that is the power electronics. And there's a cap, right? You have to include board effects and all the other parasitics all the way through. There's a paper that I just published at DesignCon with a bunch of great colleagues from Northrop. We had so much fun on this paper, and it just got republished in the SIJ. And so,
Speaking of which, pause. Don't forget what
sure,
you're saying.
sure, yeah.
Um, SIJ, thank you for being a sponsor, but Ben has a bunch of stuff that he's published on Signal Integrity Journal. I've put the link in the show notes. So everything Ben's talking about right now, I put the links to. So I just wanted our audience to not go, but where is it? So, okay, keep going.
So to do power integrity, you have to understand power electronics, right? People
Right.
today, there's still a problem. And I love that Steve talks about this. I wonder if everybody
I,
hears him, and I think he thinks the same thing, right?
yeah,
But God bless him because he's so patient, where he talks about the state of space power today and how bad it is. If you haven't seen that talk, it's a great talk. I'll send you the link if you want it. I'm sure
okay, that'd be great.
Steve,
Send that to
yeah,
me,
it's a great
please.
talk. And it talks about the gap, right? Which is what I'm kind of touched on here. And the gap is the fact that still today, even in space systems design, and Northrop's not much different. We do space here. People don't include the board effects when they do modeling. And we're still doing modeling in tools like Sabre, but we're doing that in a pure SPICE environment, but we're not bringing in the board effects. So what that means is your model is only good to a few kilohertz, tens of kilohertz, maybe. I think Steve says maybe 100 kilohertz is as good as your model is too. But that makes no sense, right? So if you think about this, if I think about how I'm looking at this, I'm typically looking at this in a time domain. Does that mean the time just stops? And the answer is no,
Right.
right? It just makes no sense. So I tell the guys all the time, so you don't include this. So you're telling me this is a model you want me to sign off on? I can't do that. And so where I have a more recent example of something that I just saw the other day. There's this eval, right? This EVM for a rad tolerant VRM from a big semiconductor manufacturer. And I built a state space average model using Steve's method in Keysight ADS for this model. And I made a measurement because I wanted to correlate it. And I got it to correlate eventually. But at first, the model that I had in ADS didn't look 100% right to the model I had on measurement. And I was working to add in the PCB effects, but that's because I didn't have the PCB effects in. And so as I'm adding that in, that was just one of the things I was doing on my to-do list. You could clearly see there was a resonance in the ripple response. And it wasn't obvious where it was coming from at first, but Steve had pointed that it's probably due to the PCB. So as soon as I added the PCB, boom, there it was. That resonance in my model showed up like a smoking gun. And so what it came out to be was a resonance that's occurring across a cap. You can remove that cap, the resonance is gone. But this is just a design flaw that you never would have seen unless you included the PCB effects. And the designer really shouldn't have designed it this way. But again, this is the real world. And how do you know what your model is really going to do unless you have the full system model? So if I would have added that now downrange with a MCM or a substrate with an ASIC on there, I would have had even more problems, right? From a noise and jitter
Right.
perspective. And so this is where it becomes even more critical, but there's a culture change that has to happen at these companies. Some companies are doing it faster than others. Some have been doing
Yes.
it. Others are slower to adopt. And so that's
Well,
the
that's why
challenge.
you're here talking to me. And what I think is so weird, one, I want to give a shout out to our sponsor, Signal Integrity Journal, but I was talking to Eric Bogatin about this and Steve Sandler, actually. And first, Steve Sandler said something once in a conversation we were having, and he says, Judy, do you really think that signal integrity, power integrity, and EMI know which kind of electron they are? He goes, they're all electrons. We name them. But, what Eric is saying, that when he joined as a technical editor of Signal Integrity Journal, he was guiding the type of content, and he's, said he put up a Venn diagram where they all interact. And he said, that's the messy part that we need to talk about, because people don't understand how they interact. We're the ones that put labels on them.
Yeah.
That identify those disciplines. So it's helpful. And I thought, oh gosh, that is priceless.